here's another example. So the first marker that we have in this table of the 10 truths is APO B. Some of you will be familiar with this, some perhaps not. I will explain in a moment exactly what it is. I put this do not open with these worms coming out of it at the top right, because this is a slide that I have spoken to for almost 2 hours before, and I'm attempting to speak to it in a couple of minutes. But what I want to kind of make clear here is that APO B is a better predictor of ASCVD, which is atherosclerotic cardiovascular disease, when you're building up plaque in the artery wall, than LDL cholesterol. And I've attempted to kind of draw this using these cargo ships to explain it. So cholesterol and fat cannot dissolve into water or into our blood. Unlike glucose. Glucose can just freely flow through circulation and get to tissues and be taken up by cells. But triglycerides, fats, and cholesterol, they are not water soluble. So in order for us to kind of provide a solution to that problem, our liver packages the cholesterol and fats onto proteins. And these proteins, which are water soluble, are what facilitates the movement of cholesterol and fats through the blood. Together, these fats, the cholesterol and the triglycerides and the protein are called lipoproteins. There is sort of 2 different families of proteins. In this image, the blue cargo ship represents one family, and the orange cargo ships represents another family. The blue family is the ApoA1 family, and the orange is the APO B. Now you might see here the anchors coming down from 2 of those APO B cargo ships. What I am symbolizing here is that these orange or APO B proteins, cargo ships, they are able to throw down an anchor after penetrating the artery wall and getting stuck and being retained, which then results in buildup of the cholesterol that they're holding in the artery wall. Whereas the blue ones, they don't do that. So what we would say is that all of these orange APO B containing lipoproteins are atherogenic. They all have the capacity to throw down their anchor. And this includes VLDL, IDL, and LDL, the 3 cargo ships that I've shown there. And so when you measure LDL, you're measuring one, it is the main APO B containing lipoprotein, but you're missing out on IDL and VLDL. When you measure APO B, you get the summation of all of those potentially atherogenic lipoproteins. Hopefully that makes sense. Maybe someone can tell me later. I worked on that analogy for quite some time. Okay, so I just want to clarify one thing. LDL cholesterol can be a good predictor in 4 out of 5 people. In 4 out of 5 people, 90% of APO B containing lipoproteins are low-density lipoproteins. But in 1 out of 5 people, that's not the case. And what happens is, when you might underestimate someone's risk of cardiovascular disease because you measure their LDL, it doesn't look so bad, but they have a lot of VLDLs or a lot of IDLs. And so if you had measured their APO B, you would have seen a higher risk of atherosclerotic cardiovascular disease. Because we don't know if we're one of those 5 people, APO B is a better marker and a better test to order, and it's not expensive. Okay, so we've cleared that up. So how do we know that APO B or LDL cholesterol is actually a risk factor for atherosclerotic cardiovascular disease, which is the #1 cause of death. Well, we have lots of different evidence, and it's all converging and pointing in the same direction. This graph here represents, on the x-axis, is the magnitude of exposure to lower LDL cholesterol. So as you move from left to right, we're talking about greater reduction in LDL cholesterol. And then on the y-axis, this is the reduction in risk of coronary heart disease. And we have 3 different lines on here. The blue line, the Mendelian, that's genetic data. The gray is observational, and the red is randomized controlled trials. We don't need to go into the specifics, but clearly what we can see here is that as the magnitude, as LDL cholesterol is lowered more and more, we see a greater reduction in the risk of coronary heart disease. We can come back to that in question time if we need to. In recent years, there's really a lot of emphasis in the peer-reviewed literature that lifetime exposure matters, kind of like area under the curve, or similar to cigarette years. There's now this calculation of milligram years. So the amount of cholesterol that you've been exposed to over your lifetime. And what we see is that about 5,000 milligram years, that's when we start to see increased risk of symptomatic cardiovascular disease. 5,000 milligram years. The average adult in America, and pretty similar in Australia where I'm from, is about 100, their LDL cholesterol is about 125 milligrams per deciliter. If that's the average LDL cholesterol exposure they have, by the time they get to age 40, they're going to reach that 5,000 milligram per deciliter, milligram years line, which is the red dotted line in this graph. Based on this research and a lot of research looking at what happens when we lower someone's cholesterol, does it affect hormone production? Are there any significant side effects? There now is this kind of general consensus slogan within the preventative cardiology community that lower for longer is better. And in fact, if we get LDL cholesterol APO B down to physiologic levels, then we should be able to entirely remove someone's risk of developing atherosclerotic cardiovascular disease. LDL cholesterol and APO B are easily measured. Your standard lab test will include LDL cholesterol, but you can usually request APO B for between $2 and $10, depends on the country. I think in some countries it might be a little more expensive. If you can't get APO B because your doctor doesn't want to order it or it's too expensive, then non-HDL cholesterol, which is on a standard blood test or can be easily calculated from a standard blood test, is a better approximate than LDL cholesterol. And that's because it adds up all of the cholesterol on the LDLs, the IDLs, and the VLDLs. Third criteria for being a marker that we have chosen is that we can improve it. APO B can be improved with nutrition and or pharmacotherapy. We know that there's various studies that have looked at how much you can lower LDL cholesterol and or APO B through diet, particularly shifting to a plant-based diet, which seems like the most effective way to do so. If one makes quite significant changes, then they may be able to achieve a 30% reduction in their APO B or LDL cholesterol. Some of that is going to depend on their genes. On the right-hand side here, this kind of image that I've taken from a study by Kevin Mackey. It's the first publication down the bottom, the PMID 37226572. If you want to look it up, it's an open access 3-page review. This is a wonderful review that talks about how much a plant-based diet lowers LDL cholesterol and APO B and what that means in terms of atherosclerotic cardiovascular disease risk. These diets lower LDL cholesterol ApoB from a variety of for a variety of reasons. One is that they're low in cholesterol raising dietary components, so they have less saturated fats and dietary cholesterol. Saturated fats will raise ApoB much more than dietary cholesterol will, but dietary cholesterol still does have an effect for most people. And these diets also contain cholesterol lowering components. So unsaturated fats, which have the opposite effect of saturated fatty acids, viscous fibers, and then plant stanols or sterols. All of this contributes to a lowering in ApoB. And in that paper, Kevin Mackey, he looks at the typical reduction in ApoB and goes back to genetic data. We have a lot of genetic data looking at people with different genetic variations who have lower ApoB across their lifetime. If we take that data and then look at how much we can lower ApoB from making it a shift to a plant-based diet, we can calculate that if you're able to maintain that long term, because lifetime exposure matters, people with genetically low ApoB have that for lifetime. You're able to maintain that for a long time, I'm talking decades, there's approximately a 20% reduction in risk of having an atherosclerotic cardiovascular disease event. Now, I will add, that is only looking at the effect of these dietary changes on ApoB. But we know that these dietary changes will also affect insulin sensitivity, inflammation, blood pressure. So there will be a stacking of benefits. So the actual risk reduction by adopting such dietary pattern will likely be much greater than 20%. ApoB can also be improved through pharmacotherapy. So some people can get to a healthy physiologic level of ApoB just with diet. Others, perhaps because of their genetics, or maybe they are not willing or able to make those dietary changes and adhere to them long term, will need the help of pharmacotherapy. There's a lot of different compounds. I'm not a lipidologist, but I've done a lot of episodes on this and read the literature. Statins, bempedoic acid, ezetimibe, PCSK9 inhibitors. These can be used in isolation or a combination, depending on how much someone needs to reduce their ApoB by, which will be determined by the changes that they will make in their diet, their genetics, and also their risk of cardiovascular disease. So let's come back to the framework. I've gone through those two examples of VO2 max and ApoB. Step one in the Living Proof Challenge in this framework is to measure all 10 truths. And then we have built a longevity score, a longevity calculator, which you can put your results in for each of the 10 truths. And we will attribute a score of 0 if it's suboptimal, 0.5 if it's normal, or 1 if it's optimal for each of those 10 truths. And that is based on the peer-reviewed evidence. So we're pulling the data from the evidence, and then based on your gender and your age, we know what is suboptimal, what is normal, and what is optimal for each of these 10 truths. This is an example of a longevity scorecard. We don't need to go into too much of the details of the table. What I do want to emphasize here is that all of these things that we're measuring, these markers are important to all of us. But where we focus from an intervention point will differ a little bit based on the things that we score well on and the things that we don't score so well on. So in this example here of this woman, her blood pressure is great, her HbA1c is great, her fasting glucose is great, but her ApoB can do a little bit of work, her VO2 max can do a little bit of work, her bone mineral density can do a little bit of work. Her bone mineral density there at -1 is borderline osteopenia. So the things that she's focusing on will be a little different to the next person who maybe scores 1 for those things, but is scoring less for HbA1c, fasting glucose. And our framework aims to educate people so they understand okay, here's the marker, and then here's how you intervene on that marker. The goal being to shift that total score. Here it's 7 out of 10 at baseline. We want to shift that, start moving that closer to 10. So in effect, what we're trying to achieve here is using science, peer-reviewed literature to turn the lights on so that you can see the dartboard, you know where you're throwing, and you can be intentional with your lifestyle. You can be intentional with where you focus.